afternoon, everyone. Today I am going to start a new chapter, a new unit, which is basically frequency domain analysis. So, what is frequency domain analysis? Why we use this frequency domain? So, the characteristics and the performance of the control system can be verified with the help of the frequency domain. Okay, so there are basically, just like time domain response, there are some specifications of the frequency domain as well. So first, another thing I want to discuss, what is frequency domain, right? So the steady state response of the system is basically the frequency response of the system, right? So the main specifications of the frequency domain are MR, resonant peak magnitude, resonant frequency, okay, and the bandwidth, okay. And this is resonant peak magnitude. So today I'm going to discuss all these specifications in detail along with their derivations. Okay, so these are the specifications. First of all, this is the resonant peak magnitude. So the maximum value of the magnitude is called the resonant peak magnitude of the closed loop transfer function, and the frequency at which the peak value of the magnitude occurs is called the resonant frequency, right? Now another is the bandwidth. So bandwidth is the range of frequency over which the magnitude of the closed loop control system is greater than or equal to magnitude greater than or equal to 1 by root 2, right? So, or you can say that the normalized gain is greater than minus 3 decibels if we talk about the decibels. Okay. Now another specification is the cutoff rate. Basically, it is the slope of the log magnitude curve near the cutoff frequency, right? Now, what is the gain margin, phase margin, gain crossover frequency, and the phase crossover frequency? I have already discussed these in details in the previous lectures. Here I am going to just tell you the definition. So the gain margin is the value of the gain which is to be added into the system so as to bring the verge of instability, right? And the phase margin is the additional phase lag to be added at the gain crossover frequency so as to bring the system to the verge of instability, right? And the phase crossover frequency is the frequency at which the phase of the open loop transfer function is equals to minus 180 degree, right? And the gain crossover frequency is the frequency, it is represented by omega GC, at which the magnitude of the function, open loop transfer function, becomes unity. Okay, the gain crossover frequency is represented by omega GC, phase crossover frequency is represented by omega PC. This phase margin is represented by PM, gain margin is represented by GM. Okay, you can say gain margin is also equals to 1 upon magnitude of, you can say, let's say GJ omega, HJ omega, right, at omega is equals to omega PC, right? And phase margin can also be written as the phase margin will be equals to 180 degree plus the angle of GJ omega, HJ omega at omega is equals to omega GC, right? Where omega PC is when the phase of the open loop transfer function is equals to minus 180 degree, and the gain crossover frequency can be represented when the magnitude is equals to unity. So these are the basically the specifications of the frequency domain. So now I'll start with the derivation of the transfer function. First of all, the transfer function of the closed loop control system, second order closed loop control system. So in transient response analysis, we have read that TS, the standard transfer function for the second order closed loop control system is TS is equals to omega n square upon s square plus 2 zeta omega n s plus omega n square, right? See, here I am talking about the frequency response. So I put s is equals to j omega here. Okay, I'll convert the transfer function in terms of frequency response. Frequency. So T of j omega will be equals to omega n square upon j omega ka whole square plus 2 zeta omega n into j omega plus omega n ka whole square, right? So let's take omega n as common from here and we'll write it as 1 upon j square is minus 1 and I am taking the omega n common from here as well. So it becomes minus omega square upon omega n ka square plus j times of 2 zeta omega by omega n, okay, plus 1, right? Or I can write this term as 1 upon 1 minus omega upon omega n ka whole square plus j 2 zeta omega by omega n, right? So this is T of j omega. This is the transfer function. Now the magnitude of the transfer function will be mod of Tj omega will be equals to 1 upon under the root of 1 minus omega upon omega n ka whole square plus, it is minus or plus 2 zeta omega by omega n. This is the value of the magnitude, right? का whole square इधर भी आ जाएगा, whole square इधर भी आ जाएगा, ठीक है? And now let omega by omega n, for simplicity I am taking it as u. Okay, so I can write mod of Tj omega will be equals to 1 upon under the root 1 minus u square ka whole square plus 2 zeta u ka whole square. Okay, so this is the transfer function for the second order closed loop control system in terms of frequency response. This is the magnitude of the transfer function, right? Now I'm talking about the resonant frequency, right? Resonant frequency is the frequency at which the magnitude of the peak magnitude is at which the magnitude has the peak value, right, for the first time. So let's represent it by the omega r. Since we know the value of this transfer function, right, I'll take it directly. The mode of Tj omega, I'm writing the value of magnitude. I can write it as m j omega will be equals to 1 upon under the root 1 minus u square ka whole square plus 2 zeta u ka whole square. Okay, so when it will become, when this value will become peak, when this denominator will be minimum, okay, let's this denominator let will be equals to g omega. मान लेते हैं कि let 1 minus u square का whole square plus 2 zeta u का whole square is equals to g omega. ठीक है, and the magnitude has peak value only when g omega will be minimum, and g omega will be minimum when we'll go for the differentiation of g omega with respect to omega and keep it equals to 0. So let's do it. So differentiation of this term with respect to omega. Okay, so I have to put it back to omega and omega n. Then only I'll be able to do it. Okay, so here I can write it as again 1 minus omega by omega n का whole square plus 2 zeta omega by omega n का whole square. ठीक है, so इसको जब differentiate करना है with respect to omega, then I get twice of 1 minus omega by omega n, है ना, ये तो as it is आएगा nxn minus 1 into, ठीक है, into twice of omega upon omega n का whole square. ठीक है, प्लस 4 जीटा स्क्वायर इंटू ये क्या हो जाएगा इसका ट्वाइस ऑफ ओमेगा अपॉन ओमेगा एन का होल स्क्वायर. ठीक है, दिस इज, सो आई विल कीप इट इक्वल्स टू, दिस टर्म विल बी इक्वल्स टू 0, राइट. सो ओके 1 माइनस, ठीक है, और फिर ये माइनस ओमेगा स्क्वायर. ओके, ठीक है, तो अब नाउ आई एम टेकिंग this term twice of omega n square both side from both the side equals to common, and this 2 can also be taken as common from both the side. So I'm left with this omega, see it's minus of omega square, right? So this will become minus as well here. ठीक है, तो ये क्या बन जाएगा, माइनस कॉमन ले लें अगर हम, एंड दिस लेफ्ट विद, यहाँ से मैंने 2 भी कॉमन लिया, तो दिस इज ओमेगा स्क्वायर माइनस ऑफ ओमेगा एन स्क्वायर आई कैन राइट अपॉन ओमेगा एन स्क्वायर. ठीक है, दिस इज द कॉमन टर्म हो गया यहाँ पर, प्लस यहाँ के बचा ट्वाइस ऑफ जीटा स्क्वायर इक्वल्स टू 0, राइट. व्हेन आई एम टेकिंग द टर्म दिस, इसको सॉल्व करेंगे तो ओके, हैव टू सॉल्व इट हियर ओनली. यहाँ से what will be omega square minus omega n square plus twice of zeta omega n square. Okay, तो omega square minus omega n square plus twice of zeta square omega n square equals to 0. If I am taking omega n common, or omega square will be equals to here, उधर ले जाती हूँ. ठीक है, तो ये क्या बन जाएगा, ओमेगा n स्क्वायर में कॉमन ले लेती हूँ अगेन, और ये क्या हो जाएगा 1 माइनस 2 जीटा स्क्वायर, ये कॉमन रहेगा. सो फ्रॉम हेयर आई एम गेटिंग ओमेगा इज इक्वल्स टू ओमेगा एन अंडर रूट 1 माइनस 2 जीटा स्क्वायर, एंड दिस ओमेगा इज इक्वल्स टू, I can write it as omega r. Why? Because at this value I am getting the resonant peak, right? So this is the value of the resonant frequency, that which is omega r is equals to omega n under root 1 minus 2 zeta square, and this is valid only if zeta lies between 0 to 0.707, right? 70.7%. Now coming to the resonant peak magnitude. Okay, resonant peak, as I have discussed earlier also, it is the peak value of the magnitude Tj omega. It is denoted by Mr, right? Resonant peak in frequency response, it corresponds to the peak overshoot in the time domain, right? Time response, transient response for certain values of damping ratio of called zeta. So the resonant peak magnitude and peak overshoots are correlated with each other, right? There we are representing the resonant peak magnitude with the, peak overshoot with the MP. Here resonant peak is represented by MR, okay? So resonant peak is obtained when at the resonant frequency. So the value of the resonant frequency here I have derived is this, okay? So first of all, I am taking the value of the resonant magnitude, peak magnitude. So the value of the Tj omega in terms of magnitude is equals to 1 upon under the root 1 minus u square ka whole square and plus 2 zeta u ka whole square. So this is the value, right? So what I'm, let me put the value of u again here so that I can solve the, I have to divide it into two parts because the derivation is somewhat, I can represent it with MR, okay, and I can write it as 1 minus omega upon omega n का square का ये term हो गया था हमारा whole square plus 2 zeta omega by omega n whole square. Okay, so what I am telling is I have to put the value of resonant peak, that is omega r, in this equation to get the value of MR. Okay, so here even I can see here we know omega r is omega n, since omega r is equals to omega n under root 1 minus 2 zeta square. तो मैं यहाँ से omega r by omega n I am having here, तो ये value भी put कर सकती हूँ. So let us consider this equation 1, this is equation 2. So put equation 2 in equation 1, right? तो यहाँ पे omega को मैं omega r लिख सकती हूँ because I am writing m को mr. So the value of mr will become 1 upon under the root 1 minus, it is 1 minus 2 zeta square whole square. I am directly writing like this, okay, plus this is 2 zeta, that means I can write it as 4 zeta square, and the value of this is again 1 minus 2 zeta square. Okay, इसको हम यहाँ सॉल्व करते हैं. MR will become 1 upon under the root, I am solving this term, it becomes 1 minus 1 plus 2 zeta square. Okay, so 1 will get cancel out plus 4 zeta square, और यहाँ पे बन गया minus 8, 4 to the 8, zeta की power 4, zeta raised to the power 4. Okay, तो यहाँ से मेरे पास क्या आ गया, 4 to 6 zeta square है ना. तो MR will be equals to 1 upon अंडर द रूट जीटा स्क्वायर में बाहर कॉमन ले लेती हूँ, जीटा आ गया हमारे पास, और ये बन गया 6 हो गया ना, ये 6 माइनस 8 जीटा स्क्वायर. ओके, वैल्यू इज नॉट करेक्ट, 1 minus 2 जीटा स्क्वायर रहना चाहिए यहाँ. There is something wrong. Let me find out. 1 minus it becomes 1 minus 2 zeta square का whole square का, यहाँ बाहर भी स्क्वायर है, सॉरी ये गलती है, तो ये गड़बड़ है हमारा. एक मिनट, गलती पकड़ी गई, let me correct it. So now this will become, see this term whole square है इसका, ओके, तो ये हो जाएगा a square, let me find out this, a square plus इसका 1 minus 2 zeta square, a square plus b square minus twice of ab, मतलब 1 minus 2 zeta square. ओके, प्लस यहाँ पे मेरे पास क्या आ जाएगा 4g² और माइनस 8g⁴। तो यहाँ से मुझे क्या मिलेगा, लेट मी सी। ओके, माइनस ट्वाइस है और ये प्लस 1, तो ये बना 1 माइनस टाइम्स ऑफ दिस टर्म, तो ये बचा -1 प्लस 2g² अगेन है, और यहाँ बचा अगेन 4g² माइनस 8g⁴। ओके, 8g⁴ यहाँ 4 आ रही है, तो मैं यहाँ क्या गड़बड़ कर रही हूँ, 1 माइनस 2g² है यहाँ, ये 4g² होएगा ही होएगा, g⁴ 4 आएगी, राइट। तो a² प्लस b² होना चाहिए, क्योंकि मैंने फिर गलत कर दिया यहाँ पे, तो ये हो जाएगा अगेन आई एम डूइंग रॉन्ग, लेट मी वंस अगेन, सॉरी, आई एम अगेन करेक्टिंग इट। a² प्लस b² माइनस 2, तो ये बन गया 1 प्लस 1 प्लस 4g⁴ नाउ। ओके, हम ठीक हुआ, b² माइनस ट्वाइस 4 ab यानी 4g², और ये आ गया -2 प्लस 4g² प्लस अगेन 4g² माइनस 8g⁴। ये आया मेरा टोटल टर्म, राइट। तो माइनस 4g² से प्लस 4g² कैंसिल, ये +2 से ये -2 कैंसिल हो गया, अब g⁴ ये रह गया, mr विल बी इक्वल्स टू 1/4 to 8 4g² माइनस 4g⁴, 4g² माइनस 4g⁴। तो मैं यहाँ से 4 कॉमन ले लूंगी, अंडर रूट में चल रहा है, सॉरी, दिस इज अंडर रूट, तो मैं आई एम टेकिंग 2 कॉमन एंड जीटा कॉमन, तो अंडर रूट में क्या बचा 2 मीन्स 4g² कॉमन लिया, तो 1 माइनस 2, sorry 1 minus g² is left, right. So value of mr is under root, so value of mr will become 1/2 under root 1 minus g². Okay, so if we see, if we put zeta is equals to 0, so mr reaches infinity, right, and from this equation if zeta is 0, then omega r is equals to omega n, right. If zeta is equals to what I am saying 0, then mr will become infinity and omega r is equals to omega n, right. But if zeta is greater than 0.707, or if zeta lies between 0 to 0.707, when zeta lies between 0.707 to 0, then mr is equal to unity and omega r is less than omega n, and in this case mr will become greater than unity, right, and omega r will reach infinity, right. So these are the derivation of the resonant peak magnitude and the resonant peak frequency, resonant frequency.